Okay, so looking at linear data structures, we have a stack. So a stack is basically a linear data structure, which means that there is no hierarchy, no ranking between the data, and every single data is of the same level. Okay, so a stack, as the name suggests, is a stack of data. Its main principle is that whenever if we like, basically it's a stack, right? So as we know, like there's a stack of plates, we like pile plates on top of each other, and similar is the case with this. We pile data on top of each other. So first in, last out means the data that we put in at the first of the stack, meaning at the bottom of the stack, is obviously going to be the one that comes out in the end, because we have to remove every other element of the stack before we get to the data that we input first. Okay, so hence the first in last out, or the last in first out. Last in first out means the same thing, but it's just reversed. So last in, the data we put last is obviously the first one that is going to come out of the stack. Yeah. So a good real life scenario can be a bottle of three tennis balls, right? So there's a bottle of three tennis balls, right? And the ball that is at the bottom, meaning that the ball that is put first into the ball that is put first into the bottle is the one that will come out at the end. And the ball which is put at the end, which means that on top of the on the top of the bottle, is going to be a ball that comes out first, in order to get us to the last ball. In order to get the ball put in first, we take it out at the last, stacking the data put first in a stack. The data put first in a stack is always at the bottom and the last one taken out, hence the stack. Okay, so terminology and functions used in a stack. So first off, we have a push function. It's basically a term used to insert data in a stack. Then is the pop function, a function that is used to remove data from a stack. Then we have a top. A top is basically a variable or a pointer that represents or points to the last input element in a stack. Basically, the topmost element of a stack. Like there's a stack, the top pointer or variable will represent the topmost value or data in the stack. IsFull is a function that is used to check whether our stack is full or not. Then the isEmpty function is used to see whether our stack is empty or not. Okay, so furthermore, we have overflow. So overflow is adding more elements than the set stack capacity. So we have like a set stack capacity. We set a capacity for a stack, and if we try to add more elements after the stack is full, after isFull is true, then it's called an overflow stack. Similarly, the underflow stack, removing the data even when the stack is empty. So data, like we have a stack, it's empty, right? The top is equal to, in case of arrays, it's equal to -1, or in terms of a linked list or pointers, it's null. So if the stack is empty, which is true, if after the stack is true, empty is true, if we try to remove data then it's called underflow, meaning that we can't remove any data as the stack doesn't even have any data. So implementation of a stack, we can do it from two ways, by using arrays or by using linked lists. Arrays, obviously variables, and linked lists using pointers, dynamic memory, that is, by using arrays. So first off, if we look at how to implement a stack by using arrays, we first off have the top is a variable that is the index of the top element of the stack array. So basically a stack is an array, and the top element is the top variable is the index of the top element, basically. It's initially -1, and the stack is basically empty at that point when the top value is -1, because an array's index starts at 0. So by making it -1 initially means that the stack is empty. So sample code, let's go to, okay, all the sizes. Okay, hashtag define size 5. So hash define size 5 means that we took a variable 5 and we stored 5 in it. Okay, so we're going to use this for our stack's capacities. Like, so then we define a class stack. We declared a variable. We declared an array, and a variable size set to 5. Implementing stack blueprint. Top variable, the actual stack. then public a stack a constructor that initializes the top variable to set to -1. Okay, and next up we have hold up. Next up we have functions. So as I told you earlier, so we have the is full function. It's going to check if the stack is full. So if top is equals to size -1, then it's going to return true. Which means that the size, for example, if the size is 5 and the top variable is at 4, meaning that the size is, meaning that the stack is basically full, because in a size of 5, in an array of 5 elements, the highest most index is 4, because 0, 1, 2, 3, 4, 5 indexes, which means that the stack is full. It's going to return true that the stack is full in this case. Else return 0. If the stack is not 0, it's going to return 0, that is false. Or we could just use return top is equal to size -1. That's it. Bool is empty if top is less than 0, basically meaning it's -1. Okay, so it's going to return 1 true that the stack is empty, and if not, it's going to return 0 false that the stack is not empty. Or we could just use return top is equal to -1, which means that the stack is empty. It's going to return that. That's it. Okay. Next up we have void push. So this is to insert a value in a stack. So first off, we're going to check if the stack is full or not. So if the stack is not full, as you can see, not full, the top variable is going to increment by 1, and then the value that we're supposed to pass, that's passed over here, is going to come in and at that point, because the stack is not full. So once we increment the top variable, meaning the index is incremented by 1, the value that we want to store is going to come in the top and in that place. Okay. Next up we have pop. To remove something from a stack. So we're gonna check if the stack ain't empty. If the stack is not empty, we're gonna initialize another variable, which is int delete, and we're gonna assign the top the data at the top of the stack, meaning obviously the stack is gonna come slowly, like the top, then after the top, then slowly comes down. Okay, so we're gonna store the data that is on top of the stack into that newly made variable, and then we're going to decrement top, and then as you want to pop the topmost element, we're just going to return that data that we stored into the variable. Okay, so that was the main basic functions of a stack. Now to display the elements of a stack. So in order to display, we first off check if it's empty. If the stack is empty, we return the stack is empty, so we cannot display anything. Then okay, so in displaying a stack, things get a little tricky. As we use arrays, so we can just simply, you might ask that we might just simply just display the array, but no. If you remember correctly, a stack works in a way that an actual stack works. We can't just remove a plate from the middle of a stack of plates, else the whole stack will fall. So similarly, in this case, we can't just remove any data from the middle of the stack. We need to go from top to bottom. So in order to display the stack from top to bottom, we use another stack. That is stack, the class's name, and then we initialize a new stack to put elements in that stack and then display them to get ordered arrangement of data, as stack works on FILO and not FIFO. FILO first and last out, and not first and first out. So this is pretty self-explanatory. Then we're gonna check. Then we're gonna put a loop while stack is not empty. So we have to keep on popping out elements until the stack is empty. So int temp. We're gonna initialize a new variable that's temp, and we're gonna pop the element. This is a function of a main stack, right? The main stack, this stack, right? This class. So as we we pop an element from the main stack, the topmost element, obviously, as you can see over here, we pop this topmost element over here, and then we just store that element, that popped element, in our in a temp variable, and then we're going to see and then we're going to display that variable after we've popped it from the main stack. And once we've displayed that that data, I keep saying variable, but once we've displayed that data, then we're gonna use a push function for the temporary stack. We're gonna push the temp data, like the one that we popped from the main stack, which is now in the temp variable. We're gonna push that data into our temporary stack. Okay, so here's the the 3 steps: stack, popped into a temporary variable, then pushed into the temporary stack. That's how it's gonna go. So that's done. While the temporary stack is not empty, we're gonna keep pushing the temp stack, and let's just go back for a second. Temp stack dot push temp. Okay, push the popped element from the main stack to the temporary stack, and then over here, what we're doing, while the temp stack is not empty, we push the element from temp stack back to the main stack. So what we have to do is we just use the temporary stack for a temporary purpose. Now we just have to, after we've displayed all our elements, we just need to push back, we just need to pop all the elements from the temp stack, as you can see here, temp stack.pop, and we're going to push it into the main stack. This is this is a function of the main stack. So we're going to push the element from the temporary stack. We pop the elements from the temporary stack, and then we keep pushing M into the main stack. So like our stack configuration doesn't get mixed up. So basically, this was all the working of a stack using arrays. Now, if you move on to stack using linked list, which uses dynamic memory, so for the key features of this is like we use a node, struct, or class. Like obviously, each data part is going to be a node. The top is a pointer, always points to the top of the list. Like basically, yeah, like the top of the list, the element that is going to be inserted at the last. Okay. Dynamic memory, we use dynamic memory. Push creates a new node by using new, and pop releases memory using delete. Okay, new is the keyword for dynamic memory to make a new a space in the memory, and delete is the keyword to delete any space from the memory. Okay, so we don't use isFull function. Stack in this case is only limited by available system memory. So as it is a linked list, we don't actually have to worry about you don't specify a capacity in this case. It's an infinite stack which is only limited by our computer's memory. Okay. Okay. So if we look at the code of this, it's gonna be we define a struct or a class called node. Okay, which is gonna have int the data part, and then the next pointer. Okay, it's a singly linked list. Next up, we have a class called stack, which is going to contain all of these nodes. Stack blueprint node top pointer. Okay, we're gonna as a class is private, we're gonna make a public constructor, which is going to be initializing an empty stack. Then we could, it's optional, but we can add a destructor to free all the allocated memory. This destructor called stack again. While it's not empty, we pop the whole stack. Okay. Hold up, it's missing something over here. Let's just fix this real quick. Okay. Anyways, now we have another function called isEmpty. It's gonna check this if the stack is empty or not. Then we have another function called push. It's gonna insert a new node inside the stack. So new node is equals to new node. We just create a new node in the memory, and then the new node's data is equal to the value, like the value that's gonna be passed from the main function or into here. So the data is gonna be the value is gonna be stored in the new node's data part. Next up, we have a new node, next is equal to top. So obviously, once we're pushing an element at the start of the stack, as we know, a stack always always is inserted at the first. An element is always inserted at the first of the stack, meaning at the top of the stack. So once we push data in a stack, so the new node's next pointer, so once we inserted the new node, is going to be pointing to the top. Basically, the top is going to be stored in the new node's next, portion, as that is going to be our topmost node of the stack. Then we're just gonna let top. We're just gonna assign new node to top so that that the top points to the node that is inserted at the last. Create a node, put top pointer in the next of new node. Done. Next up, we have a pop function. Okay, so to pop an element from the stack is empty. It's going to check if the stack is empty or not. If it's empty, it's going to return underflow because nothing to be deleted. And if it's going to return -1 because -1 it's just a decoy value, which means that is an error generated, so we can't really do anything about it. Hold up, let me just fix my camera real quick. Okay. Hold up. Yes. Okay. So let me just fix this over here. Okay. Now, that's out of the way. If it's empty, if it's not empty, the node we're gonna create a new node called temp, and we're gonna let it equal to top because obviously once we're removing an element from a stack, it has to be the topmost element. Now the topmost element of the stack is pointed by top. So we're gonna store the topmost element into a new pointer that is called the temporary pointer, and then we're gonna create a new variable int pop value is equal to temp data. So as obviously the temp pointer has the tops, everything like the tops data. So the temp's data is going to be stored into the pop value in the new variable. So then we have top is equal to top next. We're going to assign top to the previous top's next pointer, which is the second element of the stack. Top moves on to the next. Delete temp, deleted memory feed. So we deleted the pop value. Sorry, we deleted the temporary thing, and then we returned the top, and then we returned the pop value so the user knows which value was popped. Now that was the working of stack or by linked list. Now, if you want to display it, it's rather simple than the arrays. So if it's empty, the stack is empty, return. If it's not empty, we have cout stack top to bottom. We just put it. Then we create a new pointer called current, and we assign top to the current pointer, while current is not equal to null. So obviously we know in a linked list, whenever something reaches null, it means that there's nothing left. So while current is not equal to null, until current gets nulled, cout current data. Okay, simple as that. We just display the data, and then current is equal to current next. Once we've displayed the data, then we just move the current pointer to point to the next node. Okay, and that's how a stack in a linked list works. Now, if I was to show the main function. Okay, so stack, we just assign stack, we create a stack, my stack, and then my stack, we push 10, push 20, push 30, push 40, push 50. Now we have these items in a stack. Now, if I say my stack display, it's going to call the display function. Okay. Now over here, what we're doing is int value. We just made a new value, and we pop basically. We're moving the stack. Okay, we're like just moving the stack again. We created a stack, display the stack over here, and now over here we're removing the stack. So we're gonna call a pop function for my stack, this exact stack. So if value is not equal to -1, cout pop value this. So this is a stack using array. Okay, so which is why the value I said is not equal to -1, because if the index reaches -1, which means this the stack is empty. So if it's not equal to -1, pop value is equal to value, TK, and then we just removed one of the element of the top element. Okay, and then after we removed it, we just display it again just to demonstrate that we know how to remove an element of a stack. So this is a demonstration of a stack by linked list. Okay, so this is null. This is the last thing. This is the first added element, and its next is null. The second one, it points to the next one. The third one, it points to the second one. The fourth one, it points to the third one, and it goes downward like that. And the thing at the top of the stack is going to be the top variable. So that is all for a stack using both arrays and linked list. Thank you.